Everybody, and today on the bench we have some Sega and Stern driver boards for pinball machines. Both are almost identical. Sega and Stern's are just slightly different revisions, and all three of them have got similar faults. Basically we've got some resetting, so that'll be faults in the 5V section, which is here, and they've also got various stuck coils, so we need to test all the MOSFETs. For some reason the original MOSFETs that come on the Sega and Stern driver boards are actually fairly unreliable, and they do blow up prematurely until they've been replaced, so I'm sure there'll be a few that we need to find on these boards. So I'm going to start off with the 5V sections. I think most of them have actually got fairly worn connectors, like this one. This one's fairly worn, so I think we'll start by replacing the connectors. That certainly will help the situation. We also have a transformer connector there that we need to check out, and then we need to test the regulator, so we can hook that up to some power supplies and the load tester, and we can basically test the regulator to see if it's functioning correctly. Quickly showing you board number 2. Again, we've got a fairly worn connector for the power. All the plating's coming off, so it's potentially getting a higher resistance, and we've got a bit of hackery on the back. Now someone's just bodged on some wires for these MOSFETs. Not the worst job in the world, but if we look at the soldering on these chips here, it's terrible. So I need to at least neaten that up and clean it. It's been done very badly. I'll just get the third board. Board number 3. Again, I've got a fairly worn, this one's quite blackened connector. And we've got some more obvious faults in the MOSFET section. So we've got some burnt components. And if we flip the board, you can see we've got some more hackery on here that needs cleaning up. And I see it's been replaced there. Again, not great soldering. I can see, yeah, I can see the holes around those legs. They're not soldered in properly, so we'll deal with that and clean it up. So it should be fairly straightforward. It's just basically dealing with the errors as we find them. How well this is coming across on the camera, but this connector's in bad shape. That pin's crushed, and these 4 here are brown, discoloured. So we definitely need a new connector. In fact, all 3 of them are in very similar states. I think this one's got the worst conditioned pins, but they've all got some browning on them, so I'll probably replace that connector as well. It's not too big a job. So I'm just going to show you part of the load testing process. So basically we've got an input voltage hooked up to this bridge rectifier here, being supplied by this power supply here. On the output side, we've connected the load tester. We're currently drawing 3 amps. Now, ignore the voltage on there as it's not accurate at this sort of current over these wires. So we've also hooked up the multimeter on the second set of terminals. So we're basically pulling 3 amps at 5 volts. And the voltage is just under 5 at 4.9. Now if I just drop that down a bit, as you can see, as soon as we go back to say 2.5 amps, we're up to 5.1 volts. So it only starts to struggle at just 2.9. So once we get to 3 amps, it drops just below 5. That's absolutely fine though. That voltage would be fine. It wouldn't cause a reset. Obviously, providing the connectors are good. We know we've got new connectors on here. We need to reverse the polarity, test the other side of the diodes. And ideally, I'd like to also put some AC in and just check the ripple on the capacitor. Load testing is completed. I've just got to deal with some fuses that are wrong. So I'm going to blow a fuse here. That'll be related to a shorted transistor most likely. Wrong value there, wrong value there. That one's got a 10 amp when it should be an 8. That one's got an 8 where it should be 7. So we can stick that in over there. Then we just need a 3 and a 7 for their slow blows. So for the next test, we're going to test the MOSFETs and transistors. So what we've done basically is we powered up the logic section of the board. So we've got the 5 volt and we've got the blanking reset flashing because we've not got a CPU connected. We've connected up to the 20 volt rail. We're going to test the flash on transistors. So we've got the load tester across there. So we're going to basically switch on each individual MOSFET and test it for load. After we've done that, we can then switch to the 50 volt circuit. We'll supply 50 volts to the board and then we'll test the MOSFETs here. So I'm just going to go through that now. All of the transistors on the low current side, so flashes and low current solids, they all passed fine. On the high current we've replaced one that was shorted, and I'm just testing pin 6, which is Q5 I think. That one I cannot activate, so that's got a dead MOSFET, that's actually just not responding, so we'll check that one out. Also check to make sure it's not one of those resistors. If they're open circuit then you can't trigger the MOSFET, so I'll test that out. 5 bad MOSFET's been replaced. I'm just about to reload test it. Once this is passed, we can test this in a machine, make sure all the voltages, all the voltage regulators are working, make sure all the switch matrix, lamps and everything are working as well, and then this will be done. So board number 2's got a bit of a case of bad fuseitis. We've got a 10 where there should be a 7, that's a 5 where there should be a 3, and that's an 8 where there should be a 3. So all overfused. Things like this cause melted coils, so we'll put all those to the correct values. 5 volts, I'm done with the fuses. Now this one's quite obviously got damage, so we don't even need to test it yet, but we need to replace the burnt components, and then we'll test it after we've done that. Backside, we're cleaning up the soldering on that chip that's a bit dodgy. We're going to take all these big wires off, clean it up, and then jumper it a lot more neatly than it is currently. Components removed, that's quite unpleasant there, that's all burnt away, all the tracks are gone. Now I'm just going to test the resistance of that, because when the boards burn up they can become conductive, and that would potentially cause the MOSFET to come on its own or to short, and that could have been part of the reason why this board's faulty. So we're going to clean that up and test it. That is conductive. Cleaned it up as best I can, so I'm going to have to remotely mount this transistor, which is going to look ugly as hell, but I guess we've got to do it. I don't know where I'm going to mount it yet, but yeah, I think we should be able to put the capacitors back in. I'll have to check that they're not shorted out by that, but yeah, that part there will cause the MOSFET to leak as small amounts of current, potentially be able to turn it on. So I'll have to maybe mount it up here or something. Put some insulation down, glue it on. There's no ideal place really to mount it on this board. That's this one, but it looks like we can probably save Q6. That doesn't look like it's burnt, so it's probably not conductive. I'll measure it, and we've at least still got the ground pin present on the top, whereas on that one it's gone. So I think we can reuse that one, then just jumper it on the back carefully. For an idea, I've managed to drill out all of the conductive area where it's all burnt. I'm going to try gluing on some matrix board to basically give it some new holes. We'll see if that works. I'm just going to fit everything else first so that it doesn't make it awkward, and then we'll give a go at that. A little bit of matrix board, those blue lines are just to line up the holes to make sure it's in the right place. I'm just going to super glue that on. It's ugly as hell, but it's probably the best way I can think of dealing with this problem, where literally the board was shorting out the MOSFET because it was carbonised, so I had to cut it out, fit a bit of matrix board, and now this will allow me to wire it sort of reasonably normally. Obviously there are no tracks connected, so I actually do need to jump onto that after I've soldered in the MOSFET. There we go, so we've soldered in the MOSFET. I've not cut the leads yet because I want to basically join some wires on, then I'll trim them afterwards. Now this Q6 one, it's not turned out too bad. We basically bent the leg over there to jump that missing one. The ground I've soldered on the other side, the middle pin's fine. So all we need to do is basically connect this trace here, which is broken there. So we just put a thin jumper wire going to that. That goes up to the resistor there, as that's not repairable, at least not easily. So it's ending up looking neater than it was with the previous bodge that whoever worked on this did. And this one, like I say, it's going to be ugly, but we'll get it working. So it's about the best solution I could think of. So that basically should be it now. Not pretty, but it's actually, funny enough, it's got less jumper wires and it's neater than it was before I touched it. So whoever repaired it before didn't do a very good job. So we've added a jumper wire there. We've got a thick ground wire there for the main ground to the MOSFET. And the other connections are made just by forming the leads. So again, it's not very pretty, but it's about the neatest we can do, given the circumstances. And again, that matrix board's pretty ugly, but it solved a problem dealing with the conductive board issue. So hopefully that should be now ready to test. So all the MOSFETs have now been load tested and they're all working fine, so this one is now ready for a gain test as well. This is the back of board number 3. Now we've obviously got some chunky wiring. We've got some dodgy soldering on these two ICs, and more importantly, if we can get a good focus on that. It looks like someone's used some sort of corrosive flux because it's kind of eating away at the board and there's blue stuff on all the pins. So first things first, I'm going to clean that up, clean up this soldering, and then carry on testing. Yeah, so the soldering's been cleaned up on those ICs. Let's get these wires cleaned up. Look at the pins bent over on this one, practically shorting out, so we need to crop those off and get another untidy wire. We'll sort that out. Right, and there we go. That is all tidied up and cleaned up now, so that's looking a lot neater. Let's go on and test. Got to check out the fuses. So this one here should be a 5 amp and it's got a 3 amp and it's half melted already, but it's actually still working, but it's melting, so we'll get rid of that in the bin. And this one should be 3 amp and it's got a 5 amp in it, so if that one wasn't melted we could just swap them, but we'll put that 5 in there and then we'll get a new 3 amp for there. Load testing has completed, time for an in-game check. Number 3, I've tried load testing all the power outputs. The 12 volt is missing, so I've basically hooked in power coming in on this side of the fuse holders to eliminate the connectors and fuses. I'm getting nothing out at the bridge rectifier, so potentially we've got a bridge rectifier fault there, so I might need to replace that. Board free in machine, just doing a quick voltage check, then we're going to connect everything up and go through some tests. And this one does not boot the game at this time, so we need to investigate further. There's board number 2, and I can see we've got some locked on lamps and the 7 segment displays are showing garbage, so that one's not correctly working. Board number 1, tested the voltages, they're good, so we'll power up now with everything else connected. It's booted, blanking signal's active. We'll see. Okay, that looks like we're probably good. I'll just conduct some further testing. No locked on lamps and the 7 segments are working. Just doing the coil test, and interestingly a large number of the coils are not working. So let's just have a look, wait for it to go back round again. So it seems these boards are a lot more broken than the person who sent them to me thinks. So 1, 2, 3, 4, 5, 6, 7 works. So 7 works, but there's a whole bunch out there. No, most of these don't work. Okay, interesting. Let's have a look further. Had a poke around the board, we had a couple of bad fuse holders, so we've sorted that out now. Let's go for a coil cycle test. So those stepper motor ones I'll need to do in a separate test. Okay. Alright, stepper driver lines are running fine. We know that's running fine. And LEDs are running fine. I've already done all the lamp tests. Lamp tests are fine, so this one's now done. This is the board that was having the lamp problem, and as you can see that's now gone. Basically replaced 2 of the column drivers and they're all working now. 2, and we've fixed the lamp problems. Now we're going to do the coil test. Yep, boring video, I'm sorry, but I just need to go through everything. Okay, everything coil rated is working. Just going to do what I did with the other board. Quick play test and then we're done. Back on board number 3 now, and we've got the reset light flashing. And I checked pin 7, the strobe signal is missing. Strobe signal comes from the lamp matrix. The output on U6 appears to be missing, so we're going to try replacing U6, I think. Desoldered and replaced the U6, so let's give it a test. There you go, blinking light is on, so I'm going to connect everything else up and give it a full test. Going through the lamp test, there's a whole bunch of lamps that are out, so I'm going to assume that someone stuck some voltages through the lamp matrix and that's what killed the blanking signal. Let me just turn the light off. Let's see if we can do this. So column 1, yep. 2, 3, 4, 5, 6, nothing. So 6 appears dead. 7, yep. 8, nothing. So let's do 6 and 8 on the columns. So rows 1, 2, 3 is nothing. 4 looks like just one lead's come on, one's come on. So 4's bad. 5, 6, 7, 8, 9, 10. Now let me just do the lead test. Yeah, not right, that's obviously related to lamps. Yeah, we've got a few columns and rows that are out. We're doing a coil test. It appears we got a whole bunch of bad coils and flashers, so I'm imagining someone shorted out a coil through the lamp matrix at some point on this one. Anyway, let's do it. So 1's out, 3's out. I can hear the magnets. 11. Stepper motors in a separate test. Flash, a flash. Yep, so there's a whole bunch of stuff to sort out on this one. That's the U6 IC there, and we can see that it is bad on 2 of its outputs. I've got a ton of lamp matrix problems, so I was testing the signals on U18, which is another 273. It looked like a couple of lines were stuck, so I stuck it in my tester after desoldering it, and you can see, yep, 2 dead. So I'm just going to stick a socket in, get a new 273 in there. Problems with this, it appears that signals on the data bus are being pulled high and low, so I'll basically be going through testing every IC. This one here, U9, that's a 245, just pulled that one out because that appeared to have a stuck signal. Stuck it in my tester. We've got 2 lines that are being held high. These 2 here are also suspect. These are in the banks where we've actually got non-working coils and flash lamps still, so I'm going to check those out as well. But so we've got 1, 2, 3 bad ICs so far, probably 5. I'll carry on with this now. We've pulled off U4. It's in the tester. And 3 bad lines, so we're seeing a common theme here. I can only imagine someone has shorted coil voltages through the lamp matrix and that's killed a whole bunch of circuitry by putting 50 volts across the entire data bus or something. It is totally possible. I've seen this sort of thing before. So I'm going to test this one as well. I suspect it's going to be bad because I think it's bad, and I've been right on every other one so far. U1 is out, it's in the tester, and it's bad. So we're right on all of those. Just going to double check the remaining ICs, get some sockets in, get everything replaced, and then we can retest in the game, and hopefully most of the functionality is restored. I suspect that we've probably got some dead drivers though, as let's say something's taken a whack of voltage and basically chucked it up through the data bus. I imagine whatever CPU board was connected to this at the time also took a big whack on the data bus and probably is also dead. In all the replacement ICs on this now, apart from this one, which is the 245 from the input. Let's have a look. Which one is it? So on D1 we're getting 1.58 volts at idle. Should be 0 or close enough to 0. So we need to investigate that. Something is pulling that line high. That's going to be causing invalid states. Been having an absolute nightmare with this board. It's got so many faults on it. So we've also replaced the two 138s which do the address decoding, because I noticed that we were missing some of the selects on the ICs. This 74 here was dragging down one of the data lines, and I've just been scoping it on the machine basically, and it looks like all the signals are good now, so I'm going to start reconnecting other things and see if we can get it to work. Sega board's back in. You can see I've got a scope probe attached to it at the moment. I've just been going through everything, trying to get it working. It's probably the most broken that I've seen a driver board in a long time. So I'm sure, as I said from the outset, someone must have stuck some solenoid voltages through the lamp matrix and blown up a whole bunch of chips. We've replaced most of the ICs on it now, and I think we've got good signals. I've just been using my Rigol, which is out there in a minute. So just powered up. We're going to go through the lamp test, as that's one of the obvious indicators of whether it was working. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All good there. Let's just move across. A little bit fiddly on these diagnostics on the Segas. They are a good idea, but they could have done with 4 buttons instead of 3. Right, so 1, 2, 3, 4, 6, 7, 8. All the lamps are working. Let's do the solenoid test quickly, as I know that was actually not working originally. On the the stepper motor test on the Warrior. Warrior's moving forward. And then hopefully backwards. Yep, Warrior is working. That's good. Brainbug. Brainbug's working. Right, just pause a second. I'm going to step through the coils. The coil test, now we had a whole bunch out before, so hopefully we're all good now. I can't really hear the magnets, but I can hear them buzz, so I know that they worked. Now you can't see the stepper motor test obviously here, so that's why I do it separately, because that won't actually drive it backwards or forwards, just doing one at a time. So we're onto the flash lamps. And that's it. That's the test. Sorry, it's a bit boring watching these tests, but I like to go through everything on particularly problematic boards and make sure it's been documented that everything's working. I'm going to do a quick play test just to make sure it's 100%, and then we'll call this board done.